USB, or Universal Serial Bus, it seems to be everywhere, doesn't it? What started out as a handy means to connect your printer, well, it's now everywhere. Be it your mobile phone, this microphone, that camera, or even your electric toothbrush. Everything these days seems to be connected or powered using USB. Now granted, it has moved on a bit. We're now using this USB-C connector. And a further subset of that is called USB-C PD power delivery. And that's used for powering things like laptops. In fact, my own Dell laptop, that's how it's powered. So if we consider that in the world of our retro computers, one area in particular is their power supplies. That's always the weak spot. That tends to be the bit that fails first. So why can't we adapt USB-C power delivery to run our retro machines? Well, that's exactly what Andi from Hack Build Restore has done. He has came up with this little board, or should I say this little power supply that uses the USB-C PD system, and this is intended to power an Amiga. Now he's very kindly sent us a kit here. We've got a blank PCB and a lot of bits to stick on it. So let's start with that. We'll spin around to the desk behind me and let's try and get it put together. So this is the juice box, and the first thing I'd say about it is that this is a lot smaller than I thought it would be. Very compact little design. By the time we put it into this project box, well, it's going to take up a lot less space on your desk than an original Amiga power brick. So yeah, this is very impressive stuff. Now Andi has done his own video on this, just going over the design and build of one of these boards. I'll leave a link to that down in this video's description. If you didn't know, Andi runs his own YouTube channel, Hack Build Restore, or HBR for short. He does a lot of similar stuff to what we do here on CRG. So if you enjoy these videos, no doubt you'll enjoy Andi's videos. Please go and check it out. But yeah, he's labelled this as an Amiga power supply. In fact, on this little board, which caps off the end of our project box there, he's written on that it can supply 3 amps at 5 volt or 1 amp at a 12 volt or negative 12 volt. And indeed our juice box here is using the USB-C PD system, and it's using the 15 volt variant of that. USB-C PD can go up to 20 volt in its sort of standard arrangement. It can go up to 48 volt, I think now, in its extended PD 3.1, delivering up to a maximum of 240 watts, I think. But certainly if Juicebox here can meet those power demands as written, that will be more than enough for running an Amiga. In fact, it would be more than enough for running quite a few retro systems. I know Andi intended this for an Amiga, but I have an idea that's just popped into the back of my head. We'll save that for a future video. For now though, we do need to put this together. There is quite a bit of building involved in it. We have quite a few components to put on here. The board is double-sided. I'm not sure how many layers it's made of. At a guess, I would say it's probably a 4-layer board. But we've got components to fit top and bottom. Well, assuming that's the top. So let's just start with that, shall we? Andi has put everything onto this very handy sheet. We even have a tick box there to mark off when we've got everything fitted. So capacitors first. C, 3, 4, 5, 6 and 12. 3, 4, 5, 12 or 6. It's on the bottom side. And I know I said I'd do the top side first, but to save me losing any components, let's just build it as it comes, will we? This other one, it was to go there, a position C6. We'll ignore the electrolytic caps for now. Let's go down to item number 6 here, C10. I'll try and get it on. And I'll just keep going here. We'll do all of these little surface mount components And then we'll have a think about some of the bigger bits. That's all the small surface mount stuff on. Those LEDs there in particular, they were very difficult to do. Very skinny components. If I was to make a slight suggestion, those two resistors could possibly be pulled up the board a bit. Those LEDs rotated the other way, and maybe use 1206 rather than those. But a minor niggle, I suppose they're on there now. So let's just finish off this bottom side. U3 here, along with U2 and U1 on the other side of the board. These are step down converters, so presumably these are providing our various voltage rails, the negative 12 volt, positive 12 and the positive 5. Pin 1 indicated by the little arrow. Pin 1 on the IC indicated by the solid line. I need to put that on like that. And it's quite a big footprint this, so we shouldn't need the magnification or anything. And then U4, arguably the most important chip on this, because it's this one that does the power delivery negotiation. See, USB-C PD, well, if you just plug it in, it will just give you the usual 5 volts that you get with any USB cable. But it's also capable of providing 9 volts, 12 volts, 15 or 20. Now yes, PD 3.1 can go up to 48 volts, but we're just dealing with PD here, which has the maximum of 20 volts at 5 amp. As I said earlier, Andi is using 15 volt output to power this board, and the negotiation for which power delivery or which voltage level of power delivery is derived from your PSU is done by that chip. So I mean, you could in theory change this to negotiate 20 volts at 5 amp, giving you a maximum of 100 watts to play with. At the minute, Andy's negotiated 15 volts, which at 5 amp has given him a maximum of 75 watts to play with. Still plenty, you know, for the Amiga. But I do wonder if a slightly higher output version of this could be designed just to try and tick the power supply requirements box for other retro computers. Or maybe even for heavily expanded Amiga. So we'll just finish off the bottom side now. L1, L2, L3. Those are inductors. That's these things. These will be smoothing out our voltage rails. That is one thing that I am keen to test with this, because another USB power supply that was done for the Amiga wound up giving problems on the screen. You know, you could see like artifacting on the screen or like rippling on the image. That was all caused by noise on the power supply. So I'm keen to see if there's any such issues with our juice box here. I have full faith in Andi though. I don't think there'll be any problems. Right, just the electrolytics and then the USB socket to do. Should have done this one before that last one. It's going to be a bit tight getting into the back of it, but I'm sure we can do it. I have sort of purposely moved it over on its pads to the right hand side there, just so I can try and get in here. Or try and get in here without melting anything. There we are. Okay, so USB socket. That should snap into position in those 4 mounting holes. Let's see if we can get those soldered down first. And then we'll just drag across the pins on the other side. This is probably the finest pitch thing that you need to do on this board. So I'll maybe just go over this with a bit of magnification just to be sure that we haven't bridged anything. I don't need anything exploding on me when we try to power it up. Oh, well done. I've managed to partly melt the back of the socket there with the iron. I sort of just expected that the plastic on that would take you know, a little knock with the iron, much like the plastic, say, on the bottom of those capacitors, but yeah, maybe not. I think it's on there, but I will inspect it later, just with the magnification. But I think for now, that's pretty much all we can do. So I'm going to tidy all this up. It's covered in flux. I'll give it a really good clean. I'll inspect that, as I said, and then we'll have a think about trying to get it in there, along with that switch, these ends, a purple wire, because of course it's purple, and the Amiga's power connector. Cleaned up pretty well. So that will go in there, like so. The power switch presumably goes in there. And then that, well, that can only go like that. No, like that. With that other end then going on there. But we need to run a couple of wires first. So I need a pair of wires from that to the switch position over there. We need to make off our purple cable to those points. That purple cable does seem very tight in there. In fact, there's an awful lot of cores in that. We only need 4 cores for the Amiga. I think there's 8 cores in that. This is a bit of Cat6A. I'm not sure what the current carrying capacity of Cat6A is. I mean, I suppose there's 8 cores, so you could parallel the cables. Although I might see if I've got something else that might be better suited to it. In the first instance though, I think we'll just hook up the switch. Just got an old Molex connector here. We'll cut up some of that black wire, that'll do for the switch. And then we can power this up just to test it on the bench before we put it anywhere near the Amiga. I'm sure if we were doing right here, we'd use spade terminals to connect to the switch there, but it'll be fine. So let's test it. And we're going to use this power brick. One of the very few things I have about the house actually that supports PD output. It's written there in the small print. It does do PD 15 volt. So hopefully this will work. We'll stick our probes into a ground pin and the negative 12 volt pin. We'll just start with that since that's the first one there. Let's turn it on and see what it does. Negative 12 volts. That's a good start. So next pin up there is 12 volt, positive 12. And yeah, that's not looking good. Positive 5. That's equally not looking good. So I had a quick chat with Andy. He's recommended fitting a cap here between ground and pins 1, 2 and 3 on U4. That's a chip that does the negotiation. He's run into a problem with JuiceBox in that that chip seems to get reset, causing a power dropout and causing issues with the negotiation between JuiceBox and whatever you're powering it with. Now this is a Samsung power brick. It's actually my son's power brick, so I need to make sure I don't blow this up or I'll be in trouble. But it is definitely rated for 15 volt output at 3 amp. So this definitely should be able to do it. Let's give it another go. So that LED's coming on, but I don't actually have any instructions for this to tell you what the 2 LEDs do. Considering that came on when the power brick is plugged in, is that telling us that it's getting power, you know, power good is coming into it? Would D5 turn on when we perhaps turn the switch on? Well, no. But what's it doing in terms of voltages now? Are we getting any output? So negative 12 is still there, but positive 12 and 5 volt are just the same. Well, we're a few days later. Had a chat with Andy about it, and we think the problem might have been the charger I was trying to use. So the Amazon van is just away. and I now own a brand new Anker charger, although much like the Samsung charger, this is rated for 15 volts at 3 amp output, but supposedly there are differences in how different chargers or power bricks actually do the negotiation. So let's just try it. You can see I've removed that additional capacitor again, because Andy did say it should work without it. It just seems to have like a reset problem. And interestingly, this time you can see that that LED is sort of flashing off and on. Now if we try to actually turn the thing on, there's the power on LED now flashing as well. So is that reset problem that Andy was talking about? Do we need to put that capacitor back on? Right, one ceramic bodged into place. Let's offer some power to it again. But the LED is still flashing there. Now if we turn it on, yeah, it's still just doing exactly the same thing. If we take a look with the multimeter, well, the power going across the switch, you can see it jumping about there. Most of the time it's sitting at around 5 volts, and then it tries to jump up a bit, up to around 8 or 9 volts there. Almost as if it's trying to do the negotiation, and then it falls out with it. But looking up the datasheet for that IC, it's a CH224K. And as it describes here, there are two different ways of doing the negotiation. Now the way Andy's doing it is as described here in section 5.2.2, level configuration. So Andy currently has pin config 1 tied to ground, and pins config 2 and 3 tied to VDD, which is about 3.3, 3.4 volts. Config 1 pin is on this backside of the IC. Can't actually remember which pin it is. I think it's that one there, which would be pin 7. But configs 2 and 3 are on pins 2 and 3 on this side of the chip. The VDD pin is on pin 1. That's why Andy has those three shorted together. But there is another way of doing the negotiation, and you do it all on pin config 1 as per this table in section 5.2.1. If we were to tie pin 1 to ground through a 56K resistor, that should configure this thing for 15 volts. Now I'm not sure what we'd have to do in that situation to pins 2 and 3. It doesn't say there, so I'm not sure if it's okay to leave them tied to VDD as they are, or whether or not those pins should perhaps be lifted. Perhaps they should be floating. So I think what we'll do is we'll remove that chip. I'll just lift those 3 legs on it, and then we'll put 56K resistor between config 1 and ground. Let's just see what happens. See that pad on the bottom of it there? That's supposed to be a ground, which I think we're supposed to make to that. So I'm wondering, is the issue that this chip hasn't been grounded properly? That's why it hasn't been working, because the chip itself hasn't been working properly. I'm going to put this back on using a bit of solder paste. I put far too much of that on, so I will just have to touch it up here quickly with the iron. Okay, now for a 56K ohm resistor, I don't actually have one, but I have hacked together a 51K and a 4.7K, and it measures out to 55.9, so I mean, close enough. Okay, it's a bit hackery-jankery, but let's see what happens now. Hey, this looks good, because that Power Good LED there, that's came on and it's a lot brighter this time, far brighter than it's ever been. So what voltage do we have across the switch? This should be the negotiated voltage. So this should be 15. And would you look at that? 14.91. That's close enough to 15 for me. So let's turn it on. Seems to be happy enough at that. What are our voltage rails like? Positive 5. Yep, pretty good. Positive 12. Bang on the money. And negative 12. Yeah, that is perfect. I'm sort of half tempted to undo this mod here, try and bend those legs back down and solder them back into place. Although I am conscious that you can only bend them so many times before they snap off. Or in fact, I don't need to bend them. I could just blob a lot of solder on this side, and then over here I'll try and just patch a wee wire or something like that. Right, let's see what this does. That power good LED has came up bright again. Let's just measure the voltage across it. Yeah, it has negotiated the 15 volts again. So that just must have been me doing a dumb and not having that chip soldered in correctly. We'll turn it on. There's our 5. There's our 12. There's our negative 12. What an idiot. Alright, I'll tidy up all that solder work. I suppose we'll put that capacitor back on as well, just because Andy did recommend that. And I'll clean up the flux and we'll put it into its box. Okay, we've made off Andy's purple wire, ready to go. But as you can see there, I put a bit of heat shrink at this point. I had to cut the sheath of this back to be on the edge of our juice box here, just because it's so thick. It was interfering with getting it into this project box. A bit of heat shrink there is just holding everything together where the sheath is missing. So let's try and get this in here. Should just about go together. It is still very tight. So what I'd maybe recommend to Andy is just make the hole there just a little bit bigger for where the cable's going through. But I reckon I should be able to get these screws into it. So I think we'll test it using the 500 plus here. I've got the lid off this because I've been using this as a test platform for the Diego board, but I'll be well suited to testing our juice box here because this 500 plus, it's got an additional 0.5 meg in the trapdoor, and it's also got the Spitfire with its onboard 8 meg of fast RAM and a CF card. So not a heavily modified machine by any means, but slightly modified. I think it'll just be a good test of this thing. And yes, I have double checked that the voltages are coming out on the right pins. Or at least I hope I have. Because once I do this and flick this switch, if I've got it wrong, something's going to go bang. Heard the floppy drive seek. And hopefully it is booting to the CF card. Yep, there it goes. Now what I've done is record a bit of footage of this 500 plus just running off its original power brick, and I want to put them side by side here just in Workbench just to see if you can notice anything on the screen, any artifacting, anything like that, anything that might be noise coming into the Amiga from our juice box. And other than a very slight difference in image brightness, which I think is maybe just being caused by different 5 volt levels coming from the two PSUs. But other than that, I don't really see any difference. Both images seem quite stable. In fact, if we zoom into it, well, from the A500 PSU, there is maybe just the tiniest bit of shimmering around that RAM disk logo, whereas from the juice box, I don't see any of that at all. How about we try a game? Just so we can play a bit of sound as well, just to hear if there's any noise or anything like that coming into the audio side of it. In fact, how about we take silence from the Amiga? I'll increase it by, I don't know, 20 decibels, and let's just hear if there's any difference between using the juice box or using the original power brick. And yeah, again, can't really tell any difference there. But let's go for a game. Let's try a bit of Bobble Bobble. And if I put this side by side again with footage recorded from the 500 Plus running off its original power brick, don't really see any difference. Everything looks good. And the reason I want to use a 500 in particular here is because I personally think the 500 has the best video output out of any of the Wedge Amigas. Okay, I've removed the keyboard again because I want to try and test the voltage levels across the board. I'm just going to do that on the 5V rail and on some of the 7.4 series logic, just because it's handy picked up on that. So if we go to U32 here, now when we measured it inside the juice box, it was 4.99, I think. With it being loaded across this board, we're at 4.87. That's fine. I dare say we are getting a little bit of volt drop through that bit of Cat6 cable. I'm not really sure what that is rated for in terms of current carrying capacity, but it does seem quite thin. I have paralleled the cables inside it, used 2 cores for, each voltage rail, but that might be causing a slight bit of voltage drop. So we've measured at this point of the board. Let's just say go up here, measure up here. It's the same 4.87. There's another bit of 7.4 series here, if I can just get onto it without shorting anything to the floppy drive. And that's just the same 4.87, so pretty stable across the board. The other thing I would like to try and do is see if we can measure any ripple. For that though, I need my little oscilloscope. Now, this being a cheap AliExpress scope with cheap AliExpress leads is not the way to accurately measure ripple. But let's just see if we can pick up anything at all. So we need to put that into AC mode. Change it to 1 times. That's on 1 times. And we'll turn that away down to 100 millivolts per division. And that's sitting there at about between 60 and 70 millivolts peak to peak. How does that compare to the original power brick? Well, judging by this, if anything, it's actually slightly better. That's sitting there, jumping between 70 to 80 millivolts peak to peak. Now, as I said, not really the way to test for this. You shouldn't really have a long earth loop like that. You should be using a little earth connector, directly off this. You want to keep your earth loop as small as possible, and you want to be using a slightly better scope than this one from AliExpress, which I think costs about 30 quid. But comparing the 2 power supplies using all the same equipment, very similar. If anything though, the juice box is slightly quieter in terms of AC ripple. Well, that's the juice box. One very impressive and very compact little power supply for your Amiga. Although, as I said earlier, I think I'm going to try and transplant this into another system which I have that needs a PSU. Because while Andi designed this for the Commodore machine, at the end of the day it is just a power supply providing 5V positive 12 and negative 12, and I have something else that needs one of those. Now you might say, yeah, if you have this, you need to go out and buy yourself one of these things. So why not just go and get another off-the-shelf PSU solution for your Amiga? And that is a very valid point. But I do see these sort of power bricks becoming more common in the future. And this big one that I just picked up there from Amazon has cost me under £30. Plus it comes in handy for super fast charging your phone and any other devices that you may have. So It's not like this is purely limited just to powering this. This will have plenty of other uses around the house. Equally though, I do think Andi should consider marketing this thing towards the entire retro computer scene, because I do see it being a very versatile thing. So I'd love to hear your thoughts on it. If you are interested in getting one of these, head over to Andi's channel. Make sure you're subscribed to that, because no doubt he'll be putting updates on there for when these will be available. As I understand, he is planning to make these available through a local online retailer, so hopefully everyone will be able to get one soon. But that's going to be it for now. Thank you very much for watching, and I'll see you next time.